So in this problem I have a crate, and that crate has got 100 kilograms of mass. Okay? And it's just sitting there on a wooden floor. We're going to say that it's a frictionless surface, so we're not going to deal with any forces of friction. Actually, friction will be the next subject. Okay? And we have two people pushing this crate. Now logically both people would be on the same side pushing it, but that's not what we've got here. Instead, we've got a person that's going to be pushing with a force in this direction of 50 newtons. Oh, wait a minute. Sorry, not 50. 40 newtons. Okay? And then we have a person in this direction that's pushing at 20 newtons. Okay? So I have 40 newtons in this direction. Excuse me, let me rewrite that so it's a little clearer. 40 newtons in this direction and 20 newtons in this direction. The question is asking, what is the net force on the object? What is the acceleration? Just write acceleration. Okay? And in what direction does it go? Okay, first things first, the net force. Well, here's the deal. Because we're dealing with vectors, we're still going back to this idea of the sum of the forces is equal to mass times acceleration. Okay? Now, normally I would ask you to think of it this way. Instead of just the forces, we're going to say all the forces in one direction produces an acceleration in that direction, which means that all the forces in the y direction produce an acceleration in the y direction, and all the forces in the x direction produce an acceleration in the x direction. Now, by saying that, I'm saying that also that the forces in the y have no effect on the forces in the x, and the forces in the x have no effect on the forces in the y. Now, it's a mathematical principle. It's called orthogonality. When vectors are perpendicular to each other, which they are in this case, they don't affect each other. They're independent. Okay? I can do it this way. This is actually an easy way of doing it. So I want to figure out my acceleration in my y and my acceleration in the x, and I can say my force in my y was 40 newtons. Okay, so that's going to translate to 40 newtons in the y is equal to, now the mass was 100 kilograms, trying to not write off, and then there's my acceleration. Math turns out to be nothing more than 40 newtons divided by 100 kilograms equals a. So my acceleration, only in the y direction, keep going this way, my acceleration in the y is going to be 0.4 meters per second per second. That means that it's accelerating at a rate in this direction of 0.4 meters per second per second. Okay? Cool? So pretty small acceleration. Now, I can do the exact same thing for the x direction. And let me grab a rag real quick so I can clean off some space. Okay? So in the x direction, I should actually write over here. So the forces in the x equals mass times acceleration in the x. In the case of the x direction, I have 20 newtons of force. The mass is still 100. Now, this is kind of an interesting point to make. We're looking at that mass being both 100 in the y and 100 in the x. And the reason why I can make that claim is mass is not a vector. It's a scalar. And scalars can jump from one system to another, from one coordinate to another. When we're talking about the y, a scalar is still there. When we talk about an x, the scalars still translate. We saw that in kinematics with time, and now in forces we're seeing it with mass. Now the 20 newtons and the 40 newtons, you have to be very careful in what direction they're in. Okay? And then finally, looking back at this equation, the acceleration and the x-axis. So we're left with 20 newtons divided by 100 kilograms is equal to the acceleration, and that translates into 0.2 meters per second per second. Okay? So all in all, we have our system here, and we have our known accelerations now. of, let me write this a little bit bigger so we can see it, 0.4 meters per second, and over here 0.2 meters per second. Okay? Now the direction, we can do that too, but the first thing I want to do is like, I kind of got my net force, my 40 and my 20, I have them separated. We'll go back and look at it, and we'll do it a different way here in a second. We have our accelerations. Well, it's 0.2 in this direction, 0.4 in that direction, so it looks like it's going to have something like this. And then we still need to determine the direction. Now, acceleration, like force, is a vector. So what I'm going to do is I'm going to draw what that looks like. So 0.2 meters per second. So this is the acceleration in the x. Then I have 0.4 meters per second in the y. And the direction I'm looking for is right angle. This right here, I'm looking for this angle right there. Now, how I'm going to do that is I'm going to look at what I know. Well, I know this and I know this. I know in trigonometry, I know the opposite and I know the adjacent. Okay? So what I'm going to do is I'm going to say, well, I know so is sine theta is equal to opposite over hypotenuse, this being my hypotenuse. My ca is cosine is equal to adjacent over hypotenuse, this being the adjacent, and then toe with opposite over adjacent. So tangent theta is equal to opposite, which is this side, 4 over 2, 0.4 over 0.2. Okay, I'm not really about carrying the units over in my angle. This is really not that important to me. I'm left with the tangent theta is equal to 2. Okay, now how I get theta, the angle that's associated here, is that I'm going to take the inverse tangent. I'm going to do an operation on both of those sides so that I can get theta by itself. Okay, I'm left with theta is equal to the inverse tangent of 2. Okay, now I'm going to have to get a little bit more of a complicated calculator. Ta-da! So I'm going to hit, first thing I'm going to do is I'm going to check the mode. I want to see that it, look, it's in degrees. I need it in radians. Okay. Quit. The next thing I'm going to do is I'm going to simply say, well, looking at my calculator, right here is a button that's in blue that says tangent -1. Second tangent, and the result I have is 2. And from there I get 1.107. Now, that's giving me the answer in radians, and if I went back and did it in degrees and hit inverse tan of 2, I'm going to get about 63 degrees. That's strange. Okay, so this right here says it's 63 degrees. Okay, so I now have the direction is 63 degrees. I have the acceleration that's in components, and I have the net force that's in components. Now what I'm going to do is, with this bit of information that I have, I'm actually going to go back and get more from it. Okay, I've got my degrees. And now I want to re-examine my acceleration. I have it in two different values. I have it as a 0.4 and a 0.2. So this was 2, and this was 4. Okay? And now what I want to do is I want to figure out what the length of this is. Now, vector addition, there's two ways to do it. I could graphically draw this out pretty precise and make a measurement. I'm not going to be 100% accurate, but I'm going to be in the ballpark. The other way I can do it is I can do a squared plus b squared equals c squared. So a squared is going to be 0.2 squared plus b squared, 0.4 squared, is equal to c squared. Going back to my calculator, so 0.2 times 0.2 equals 0.04. And 0.4 times 0.4, let me guess, is going to be equal to 0.16. Okay, add them together. So 0.04 plus 0.16 is going to give me 0.2. Okay, so if I have 0.2 and I want to take the square root of that, I'm going to hit second square root of hold off one sec. Okay, so I'm getting this to be 1.4. No, that can't be right. I screwed that up. How about 0.44? Okay, so that means that the net acceleration of this object is going to be 0.44 meters per second at 63 degrees. Now, we did find it to be 0.2 this way and 0.4 that way, but what we're really looking for is how much is it going to accelerate this way. Okay, so taking into account both of those, we're going to end up with an acceleration of 0.44 in that direction at 63 degrees. Now, the net force is going to be done exactly the same way. I got 20 and 40, so instead of this being 0.2, this is going to be 20. Instead of this being 0.4, this is going to be 40. So 20 times 20, okay, is going to be 400. And then 40 times 40, which is going to give me 1,600. Add those two together, and I end up getting 2,000. Well, that's not strange. And then I'm going to take the square root of that, and I get my net force to be 44.7, or how about 45 newtons in that direction. So the net result is that I'm going to have an acceleration about in that direction of 0.44 meters per second and a net force of about 45. Okay? Cool?